Bayes classification algorithm, it is a supervised machine learning algorithm that can be utilized for classifications. A lazy learner model are a machine learning model that do not learn anything during its training models. There will be prediction in order to define a class label, right? So this is a feature of a Bayesian classification. If a query is arised, only then it will start to work, and that's why it is called as a lazy learner algorithm. Hello everyone, I welcome you all to the second session that's under 6th semester. Yes, we have completed 3 units and we have step 2, unit 4, and in that unit 4 we have already completed one of the sessions. So I just request you to go back and check that video also. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor in the Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. Unit 4 is all about classification, and let's move forward and see like what are the things that we have discussed in our previous session. Yes, in our session 1, we have discussed like what is classification and why classification is required, then what is the process involved in classification, then the basic terms that we can utilize under classification, then followed by the issues. So these are the things that we have completed, and along with that we have stepped with algorithms too. Yes, fundamentals of data science is a subject where the data is been considered, evaluated and represented in a very useful format, correct? So for that, the algorithms are very crucial because they give us a proper and efficient information in order to make decisions, or it might be used for business intelligence, etc. Thus, we have stepped with algorithms, and with that, we did discuss the first 2 basic algorithms, which is none other than decision tree induction, and the second one was the attribute selection measures. So these are the 2 algorithms that we have completed in our session 1. Let's move forward and see the agenda of today's session. In today's session, we will be discussing and learning regarding the Bayes algorithm and the rule-based classification. Then we do also have something called as that is lazy learner's algorithm, which is none other than learning from nearest neighbors. So these are the things that we discuss in our today's session. So let's move forward and see what is the first algorithm, that is none other than a Bayes algorithm. Bayes classification algorithm, it is a supervised machine learning algorithm that can be utilized for classifications. This classification is done based on the probabilistic reasoning, that's by utilizing the Bayes theorem. Here what happens is there will be a prediction of the class labels. Okay, so that prediction is completely based on the observed data as well as the prior knowledge. Yes, there will be a prediction that is completely dependent on the observed data as well as the prior knowledge. Now, there comes a doubt like how this class will be assigned. Yes, the class will be assigned based on the highest posterior probabilities. This class prediction as well as the class label prediction can be practically implemented by using this Bayes theorem, or we can say that by using Bayesian networks. Now, as we did understood that we need a network, then it becomes crucial to understand like what are the things that is being involved in that network. So the things or the terms that are involved under network is none other than it starts from a simple node. Yes, a node is used to represent a feature or a variable with respect to that application. And the next terminology that is involved is links. Whenever there is a node, absolutely there should be some link, correct? In order to connect between the nodes. So that is a link, and it forms a relationship. What kind of relationship? The dependency relationship between various variables that we have defined. And we have to note that each and every link has an associated probability distributions. Thus, these are the terminologies that is utilized whenever we want to go with construction of a Bayes classification. Great, right? So let's move forward and understand what are the key features of this Bayes classification. As we know, the first feature that we can consider is this is completely utilized for supervised learning. Okay, the next feature is it provides a probabilistic model using the conditional probabilities. And the next feature is it uses prior information, or we can say that likelihood for any predictions. Yes, correct. There will be prediction in order to define a class label, right? So this is a feature of a Bayesian classification. This is not only supervised, but it is interpretable as well as mathematically sound classification method. And it is scalable for complete large data sets. This type of classification will handle not only a continuous but also the discrete features. So these are the key features of Bayes classification. Now let's move forward and understand the formula for this Bayes classification. Yes, definitely there is a particular formula. Here it is, that is P of C by X is equal to P of X by C into P of C divided by P of X, where in general we can say that the posterior probability P of C by X is equal to the likelihood, yes, this is a likelihood, into the prior probability. What is that prior probability defined as? P of C. Further, the P of X is none other than the evidence. Thus, this is a simple expression that is considered for Bayes theorem. Now, as we did understood that this is a basic representation, and in order to go forward with Bayes classification, there is some assumptions that we need to take care of. So let's see what are those assumptions, and along with that assumptions, let's also understand different terminologies as well as workflow. So let's move forward. Yes, over here, let's start understanding with the various assumptions. As usual, as we know, the first thing comes under our mind when we consider a Bayes classification is there will be prior knowledge of the data set, correct? So for that, we can predict the information. Thus, our first assumption is there will be a prior knowledge of probabilities, or in other words, we can say that the prior probabilities will be known. Then the second assumption that we can consider is the conditional probabilities are perfectly estimated. The third assumption that we can consider is the training and the test samples are completely independent. Then assumption is none other than the features are stationary over the time period. Yes, the next assumption that we can consider here is the classes that we define, right? Yes, those classes are mutually exclusive as well as exhaustive. Thus, these are the assumptions that is considered under Bayes classification method. Heading with terminology, the first terminology that we need to understand is a prior one. Correct, right? Prior, it is none other than the initial belief that is considered before the evidence. So that is none other than our prior terminology. The next terminology that is considered under this Bayes classification is the likelihood. This gives the probability of data of a given class or a considered class. The next terminology that we consider over here is posterior, which is nothing but the updated beliefs after evidence. Okay. Next, evidence, yes, absolutely, it gives a overall probability information of a feature. Okay, that is the fourth terminology. So these are the terms that we consider under Bayes classification. Now let's move with workflow, or we can say that the working steps under Bayes classification, or we can also say that how this Bayes classification is followed. So these are the steps that we have to consider. The first step is none other than collecting the training data. The training data that we have considered here is X and C. Okay, then we will particularly compute the P of C, which is none other than the priors which are available with respect to that information. Nextly, we will be computing the likelihood, that is P of X by C value. Then finally, we will be applying the Bayes theorem so that we can move forward and apply or assign a class with maximum posterior probabilities. So this was with respect to the Bayes classification method. Now let's move forward with the rule-based classification. Here, the rule-based classification is a data mining technique which is utilized to categorize the data into the predefined classes, and in order to categorize it, we will be utilizing if-then cases. What do we use? We will be using if-then cases, and this method is being valued for its transparency as well as interpretability has the logic behind each classification decision is easily understood. Let's go forward and understand like how exactly this rule-based classification works. Yes, as we know that a rule-based classification, so there will be some of the rules that we have to edit, correct? The first is none other than antecedent. So these are the rules that we have to go with. Okay, antecedent, which is none other than if condition. We will be utilizing if condition to go with. This condition parts on the complete alleged side, which is nothing but a left-hand side that consists of one or more attribute tests that is logically connected by the AND operators. So for example, we can consider that if age is equal to youth and student, then yes, absolutely, if a person is youth and he is a student, then we can say that yes, that's true, because we know that under AND logical gate, we will be getting a true value only when both the conditions are true, correct? So that is with respect to the antecedent. The next rule is none other than consequent, which is utilizing then in order to provide a conclusion. Yes, when we know that this antecedent will work with LHS, this consequent will absolutely work with RHS, that is right hand side part. And an example that we can consider is then buys computer. Yes, if he is a student and his age is according to a student as well as youth, then we can say that he can buy. Then buys computer will also be a true condition, isn't it? Because a student needs a computer, right? We agree, correct? Yes. If a given data record satisfies all these conditions, then the rule is triggered and the record is assigned. Okay. So this is how the rule-based classification works. So this is all about a rule-based classification. Let's move forward with next type of algorithm, which is none other than the lazy learner algorithm, or it is also called as learning from a neighbor. A lazy learner model are a machine learning model that do not learn anything during its training models, but instead they will be storing that training data and the computation is performed whenever a query is raised. Till then, it won't work at all. Okay, it just considers the training data and it will be storing that training data. So that's why it is also called as learning from your neighbor. If a query is arised, only then it will start to work, and that's why it is called as a lazy learner algorithm. Here we can see an image of a student. He is lying lazily, correct? And if he gets that intuition from his neighbors, or if he gets distracted through any of the query, only then he'll start working. So this lazy learner classification is also the same thing. Thus, let's see the characteristics of this lazy learner classification. The first character is there is no training phase, or we can say that if it exists, then it will be very, very minimal of. And the learning completely happens during the prediction time. This classification is very simple to implement too. Even it works well for small databases or data sets, and it requires high memory requirements. So do you know why does it requires a high memory? Because it has to store that training data and it will be considered when a query is initiated, correct? So that's why it requires a memory. And the next feature is the prediction time considered is very, very slow, or we can say that the slower prediction time is considered with respect to this lazy learner algorithms. Let's see the advantages and disadvantages of this lazy learners. The first advantage is none other than it is very easy and simple to understand and implement too. It works very well when the decision boundaries are irregular. The next advantage is there is no need of building a model. Let's move with the disadvantage. Yes, absolutely. The first disadvantage that we can coin is it requires a lot of memory and it is very sensitive to noisy data. The predictions are slow for larger data sets, and also the performance decreases as the dimension of data increases, or we can say that for multidimensional data the performance is very, very less. And this was all about today's session, and in next session we will be discussing few of the rest algorithms like k-nearest neighbor. Then finally we will be understanding what is the merit for evaluating the classifier performance, then the confusion matrix. So these are the things that we discuss in our next session, and till then, thank you.